Yeah, it was a lot of proofs for triangles
Yeah,
and stuff like that.
yeah. No, I've got like 4. This actually wasn't what you sent me. It was what one of my other Chatfield students sent me. So I just
Mm,
finished the session doing these exact same problems. Um,
all right.
okay. Now, you want to go through it as a 2-column proof?
Yeah, I think that'd be good.
What is statement 1?
Hmm. Um, AE is congruent to AH.
Reason? Oh, actually, there's more to statement 1.
And then is it also YAE is congruent to YAH?
Uh-huh. And the reason for both of those?
They're given.
And statement 2, we're trying to prove this triangle is congruent to that triangle. So we got to either have side, 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 angle, angle, side, or angle, side, angle. Got to have one of those 4 reasons since we're not dealing with a right triangle.
Okay.
In other words, a right triangle has, you only need 2 things to be equal on a right triangle. That's one of the angles and one of the sides. Whereas most triangles, you have to have 3 things. How many do we have now?
Well, we have side because of reflexive property.
Okay, let's state that. That needs to be in the proof. The only reason I say that is because well, no, I have a second sheet that has 3 problems on it, and every one of them, that's one of the steps. So I would say YA is congruent to YA. And what's the reason there?
Because of the reflexive property.
And finally, I can say what?
That well,
At this point, we've got this side is equal to this side. We got this side is equal to itself. And we got this angle is equal to that angle. So just follow
okay,
the pattern. Start with the furthest thing left that you know. Side, angle, side.
side. Okay.
Okay? And
Yeah.
just always go in order. And you can't get it wrong. So I can now say that that triangle is congruent to that triangle based on side, angle, side. Okay?
Yeah.
What are the givens in this?
For the okay. So it's YI is parallel to SE.
Okay, I'm going to leave just in the interest of simplifying it, I'm not going to put the lines over the top and everything.
Okay. And then yeah, the K is the midpoint.
Of YS. Maybe I should, just there's a reason I do it. Okay, we're trying to prove this triangle is congruent to that triangle. Also, no right triangles are involved, so we know we're going to need 3 things. What 3 things do we have?
Well, we have angle where K is the midpoint. We have angle on both sides.
Well, you're referring to K is equal to that angle there?
No, the angles that it connects between the two
That
triangles,
angle is
I guess.
equal to that angle.
Yeah.
Correct. Okay. Um, okay. So, if that angle is equal to that angle, and then that side's equal to that side, kind of stuck. Let's look at the parallel aspect of it. It's going to be
Okay.
a better way to go, and you'll see why.
Oh,
You'll see why in a moment.
could you find alternate interiors for this?
Yeah. So which angles are equal to each other?
S and Y.
So angle Y is congruent to angle S. And what else?
Would it also be E and I are congruent?
Angle I is congruent to angle E, and what's the reason?
Alternate interior angles.
Okay, alternate interior angles from parallel lines. Actually, I ought to spell that out, I guess. Okay. And now, okay, we know two angles are equal. Well, three angles being equal doesn't really help us, right?
Yeah.
In other words, for sure, I know that angle is equal to that angle, and so all three angles are equal to the other three angles, but as all that does is makes it similar.
Are
What
Y and
side?
I
What sides are equal?
ES and YI?
No, don't know that. We know they're parallel. We don't know they're equal yet. What about this midpoint? K is the midpoint. Always look at what you're given and why they gave it to you.
Okay.
So far, we haven't used that given yet. What does that mean?
Okay, so that means YS are equal, right?
So
If K is the midpoint?
K is the midpoint of YS, so what two line segments are equal?
YK and KS.
There you go. YK are congruent to Y or KS because of I think you can just say the midpoint theorem. In other words, I don't know the exact theorem or definition of midpoint, maybe. I don't know. Any of them should suffice.
Okay.
Okay. And now how many pieces of information do we have?
Enough to make angle
so
one of those.
You're right, we do. We can now say that triangle is congruent to the other triangle. Let's see, YKI, and EKS. Why?
Because angle side. No, it's not angle side.
No, we got two angles and we got one side.
Angle side.
Okay, the way you figure it out, it's one of two things. It's either angle side or angle side angle, right?
Yeah.
Those are the only two theorems that have two A's in them.
Okay.
So let's figure out what it is. Let's start there. We know that piece of information. That's a side. And now let's go clockwise. We know that, we know that, and we know that. So what we have is side, angle, which is the same thing as angle, side. In other words, I could have gone angle, we know that, starting from the left, angle, angle, side. As long as you go either clockwise or counterclockwise and you go in order, then that's the one it is. Okay? But
Yeah.
notice that AAS is the same as SAA. This one's different. This one has to be angle, side, angle. And that's not the case here anyway. But it's definitely angle, angle, side. And I don't even think they refer to that one as a reason, so we have to write it like that. Good thing there's not an ASS one, or math teachers would have to be embarrassed all the time, huh? And in fact, there is not. Angle, angle, side does not, or angle, side, side does not prove congruency. Not only isn't there one, there's a reason why there isn't one. You can actually have angle, side, side and not have congruency. Okay, let's see, that was 2. Let's look at 3. First statement.
Well, we have all the givens for one.
Okay, let's just go ahead and write those. Bisects angle A, and GA bisects angle G. So those are our givens. And we're trying to show that line BG is congruent to line NG.
Okay.
Well, the way we're going to prove that is we're going to prove congruency of the two triangles. In other words, this is the first problem we've seen where they haven't asked us to prove two triangles are congruent. But they're telling that AG bisects angle A, which means that angle is equal to that angle, and AG bisects angle G, which means that angle is equal to that angle.
Okay.
So help finish the proof here.
Well, for the next one, we could go with the reflexive property, right?
Okay. So what's the second statement? In other words, you can mix up the order of the statements and it's okay. They don't always, there's not a given right answer. I could go with the AG equals AG because the reflexive property next, or I've at some point in time got to state that that angle, BAG, is the same as this angle, GAH. So let's do that right away. I think it makes sense to keep, and you'll see why I think. I'm going to say angle BAG is congruent to angle GAH. And that's because of?
That's, I don't know what it is that proves that.
Well, I'm not sure if it's a theorem. We'll just call it the definition of bisecting.
Okay.
If she takes points off for that, then I guess you need to go look up the exact theorem. I don't have, I just know that that's what bisecting means. So that should be sufficient. But notice why that's better to put as statement 2. Because it directly relates to statement 1. Immediately. If I were to put this as statement 3, and instead of statement 2, I would say AG is equal to AG, well, I've stuck something in the middle for no good reason. I might as well keep things in order, and that's the reflexive property again. now you see, now we have that angle equals that angle, and I also have BGA is congruent to AGN. In other words, both of these sets of angles are equal because of statement 1.
Okay.
And now I have 3 pieces of information. So the next step is what? There's actually 2 more lines. Remember, the final thing is to show that BG equals NG.
Okay.
The intermediate step is to prove that this triangle is congruent with that triangle, because once we do that, we'll know that BG is equal to GN.
Is there any way to prove that the angles on G are congruent?
The triangles are congruent?
No, the angle from the bisector to G.
We don't need it. In other words, we already have our 3 pieces of information. There's 2 angles, and there's a side.
Okay.
Just which theorem are you going to use to prove that triangle BAG is congruent to triangle GAN? Why
Would that be side angle?
Always do them in order. It's not really side angle. In other words, this is the side, right?
Yeah.
If it was side, notice what I have to do side angle, angle. I got to go side, angle, angle. That's not in order.
Okay.
Either go clockwise or counterclockwise, and start with the first thing you know. I know that angle. So I know angle, side, angle.
Okay.
Angle, side, angle. Which is not the same as angle, angle, side. Okay? Just don't jump around. In other words, angle, side, angle, I'm going in order. I'm choosing a direction and I'm going in that order consistently. When you did it, you went side, angle, angle. There's no, that's not clockwise, it's not counterclockwise.
Okay.
Okay? And then finally, the 5th statement is what?
BG is equal to NG.
Why?
Because
See, they have a 5-letter thing they use. CC.
Oh, we talked about this in class.
What is it called?
CPCTC.
CPCTC. Congruent
Yeah.
properties of congruent triangles are congruent. No, sorry. Corresponding parts of triangles are congruent. There you go. That's what CPCTC means. Corresponding parts of corresponding triangles. Well, congruent. Excuse me. Corresponding parts of congruent triangles are congruent. We just proved they were congruent, and BG is a corresponding part to GN. Okay. And finally, let's do this last one. First step.
All the givens, which would be SW equals, is congruent to NW and IW is congruent to HW.
So that immediately tells us that we have 2 congruent sides.
Yeah.
Okay, so we know that we're going to be looking for either a third congruent side or an angle that would be, but it's got to be the angle in between the two congruent sides. So they're saying that line is equal to that line, and that line is equal to that line. So we have two sides. Is there an angle that is equal? In other words, picture these as two triangles. There's that triangle and there's this triangle.
Oh, yeah.
Okay? Can we show that there's an equal angle between those two triangles?
Can we use the vertical angles because of G? Or do we not know it's
That's not an angle in our triangle. Nor is that, nor is that. In other words, each of these triangles has angle S, angle W, angle I. This triangle has angle N, angle H, and angle W.
Okay.
Which one is the same for both triangles?
The one at W?
Yeah, the one that's common to both. So
Yeah.
I can say angle W is congruent to angle W. And it seems a little silly, and it's annoying that you have to do this, but especially when you're doing a two-column proof. What's the reason again?
Would that be, no,
Something equal to itself is always
reflexive.
And I've been seeing a lot of that lately. Almost every problem that I've been looking at has a reflexive property to it. So now we've got two lines and an angle.
Oh, yeah.
So we should be able to say that triangle SWI is congruent, hopefully, to triangle NHW. But is it, and why?
Would that be angle side angle?
No, we only have one angle. There's only one angle. There's two sides. So the answer has to have two S's and an A in it.
Side angle. If you
That's actually not congruent. You can't prove congruency with side angle. Plus, I want you to get in the habit of going either clockwise or counterclockwise and going in order.
Okay.
So start with that side right there. And go clockwise. Go clockwise. What do you get?
Side. Angle, side.
That's it. Side, angle, side. And I could have started with this side and gone counterclockwise. Side, angle, side. Always go in order, though. Don't go out of order. In other words, if you go side, angle, I switched directions. I was going clockwise, and then I went counterclockwise. So as long as you go either clockwise or counterclockwise, you'll always come up with the right order of these letters. Just make sure that you got two S's because of that, and you have one A because of that.
Okay.
And then just figure out the right order. And why is angle S equal to angle N, which they never really told us? That was not a given.
What is that? CPCTC?
Yes.
Okay.
Corresponding parts means angles and lines. Okay. That's pretty good. It seemed to me the only problem you really had was going in the right order and going in order. Let me just say one last thing as to why side angle is not proof congruency.
All right.
There's a 40 degree angle. There's a side of 10. And there's a side of 8. Well, this happens to be an ambiguous situation. meaning I can draw two triangles that have those dimensions. There's my 40-degree angle, there's my side of 10, there's my side of 8.
Oh, so you don't know that bottom length then?
Well, in other words, this would be, if we start from the angle and go clockwise, this would be angle, side, side. Or if we start from this side and go counterclockwise, it would be side, side, angle. But that's why side, side, angle does not prove congruency. In other words, I can have two non-congruent triangles that have side, side, angle. Side, side, angle are the same.
Okay.
Okay?
Yeah.
So just either go clockwise or counterclockwise. Don't switch directions.
Okay.
Okay?
Makes sense. Yeah.
All right, Mark. Let's see. I've got you down for Thursday at 4. Huh? No? Something's... Oh, yeah. No, your dad said he wanted you to have 3 sessions this week. I got you down Tuesday at 4:30.
Tuesday at 4:30? All right.
Come on.
Cool. Sounds good.
Okay, I'll talk to you then.
All right. Thank you, David.
You're welcome.